Now we continue with some data processing instructions. Data transfer we finished. We now go for data processing instructions. Of them, we have seen one instruction, that is add instruction, which is quite simple one. Okay, add instruction. We will take up few instructions, and then to develop a complete program, few more instructions are required for control transfer. That we will go through so that we will be in a position to write a complete program for some operations. So add R instruction is an 8-bit addition instruction. Addition instruction requires two source operands and one destination operands. 8085 being a very early generation processors, the flexibility which is offered for performing addition by the instruction set of 8085 is not much. Only accumulator is one of the default source and default destination. You can, the user or the programmer can specify one another source, and carry is also a default destination because addition of two 8-bit numbers can be a 9-bit number. Is it okay? I think it's quite simple. The next instruction which we can take up for consideration is, means what we are doing, we are taking very simple instructions first, and later on I am sure that you would be in a position to understand remaining instructions on your own. There is one more instruction, that is increment. One more instruction which is there is increment. So increment is an instruction which is having a single operand. Listen very carefully. It means now these various instructions are quite simple. It is not even worth high school level discussion. Increment is having a single operand, and it is source as well as destination. Incrementing the operand. So let us say a simple instruction, INR B. So what this instruction does? It increments, means it is, how many byte instruction it is? 1 byte, only opcode. It, what would be its operation? B is getting assigned to B plus 1. B is getting assigned to B plus 1. Similarly, or in general, increment B, or we can have increment R, or we can have decrement R also, same thing. Right? So R is getting assigned to R plus minus 1. Is it clear? Is it alright? Is it okay? Each of them is 1 byte of instruction. The operand is inside microprocessor. Therefore, everything will be done immediately. Means what? How it will operate? Opcode fetch some address, say 0008 address. Data for say decrement B. If we take for decrement B, it is 05 is the opcode. It goes to IR, right? 0. Opcode fetch. Let the instruction be at 0008 location. Instruction is 05, which is decrement B. What you are doing? It goes to IR. So when now can anyone stand up and explain what 85 will do when the opcode corresponding to decrement, when 05 which is opcode corresponding to decrement B goes to instruction register. Immediately when something goes to instruction register, the first आता लेक्चरला यायचंय, लेक्चर आहे तो आधी काय विचार करायचा यायचा आणि कशावर ठरवायचं असतं, व किती तास लेक्चर आहे, मधनं बाहेर जाता येत नाही. The first conclusion which you must get instantly is what is the length of the instruction. So at 0.5 is how many byte instruction? 1 byte instruction. What are instructions for? Decrementing register B. Where is register B? Inside processor. Where it is to store again? Inside processor. So it does not require any external cycle. So its execution takes place internally. Is it right? This when we can write execution in bracket, there itself, if that execution does not require any external memory reference. Is it okay? It is decrement B, increment C, whatever it may be. Now, this decrementing is used for some specific purpose in programs. Down counting. Suppose if that now you know that World Cup is starting on some day. So nowadays I think that practices have gone. Earlier, maybe you may ask your parents at home if there is a blackboard or some calendar, they used to put now 93 days are remaining. Just like you may be putting for now 40 minutes are still remaining to end the lecture. Right? Down counting. So mid-sem exam. From today is 25th September is mid-sem exam. So 31 days are remaining. So every morning what you do? You make it less by 130. And when it is 0, it is the kick start the event. Kick start. Is it right? Kick starting the event. Similarly, the down counting is used, decrementing is used for some purpose. So what happens is that after execution of increment or decrement instruction, increment it does not have much meaning, but after decrement instruction, each time I think he may be expert, in the flag register, he mentioned that, in the flag register, there is one bit Z bit. Flag is 8 bit register. Of that 8 bit, only 5 bits are meaningful, 3 are not meaningless, we can say. 3, there may be some people who speak less. Is that they are not doing anything in the time when they are not speaking? They are thinking. Only thing is that what they are doing is not made public. Like that, actually, when 8085 instruction set was published, that time there were many researchers who 8085 the opcode is 1 byte. So how many instructions are possible in all? 256. 256 different opcodes, 74 types of instructions, and 74 types of instructions are there, and 256 instructions are possible. But the Intel published instruction set which is having valid opcodes or valid instruction only for 246 opcodes. लक्षात आलं का? 256 FF पैकी 256 सगळे वापरले नाहीत, 247 वापरले, and 10 combinations were not disclosed. Of them 0 it is one such. Then designers or users of 8085, what did they try to do? Listen very carefully. They tried to find out what it is doing. Means if 21 is given as opcode, LXIH. So if that combination which is not published as an opcode by Intel, if it is given in the memory ते ठेवलं तर 8085 काय करत असेल हे ओळखून काढलेलं आहे. त्याला काही त्या इंटरनल डेव्हलपमेंट टीम मधलं काही मत झाले असेल तर डबल सबट्रॅक्शन, there is one more flag called as X5 flag. असं हुडकून काढलं. मग आता ते it's a very interesting question for you being especially computer students. Why Intel might not have published that? काही गोष्टी सांगायच्या होत्या आपल्याकरता ठराविक लोकांना वापरायचे होते असं असेल का? इंटेलनं काही इन्स्ट्रक्शन पब्लिश केल्या नाहीत पण प्रोग्रामर्सने ते शोधून काढल्या. तुम्ही गुगल सर्च दिलं तर नॉन लिस्टेड इन्स्ट्रक्शन ऑफ 85 दिले की ते सगळे येतात. आता ते पूर्वी हे माहीत एक जेव्हा 80 साली हे झालं तेव्हा काय असणार, अशा काही अनलिस्टेड इन्स्ट्रक्शन आहेत हे काही जण माहीत असायचं आणि ते पब्लिक नसायचं. आणि मग अरे त्याला माहित आहे असं होतंय असं एक क्युरिओसिटी वेगवेगळ्या प्रकारचे हे होते. बट नाउ इट इज that curiosity is lost because everything is available on net now. Everything is available on internet. So in that case what happens is these instructions Intel ने का पब्लिश केलं असेल तुमचा अंदाज? इंटेल ने काही मुद्दाम अशा राखून ठेवले आहेत असं काय असेल का काय? का केलं नसेल पब्लिश? Any guess? What complications? What happens? Every time you should say what will happen, what will happen. का पब्लिश केलं नसेल? बंदी घातली तर लोक मुद्दाम ते करणारच. It is likely, it is not yet made sure, it is likely that the instruction म्हणजे बऱ्याचदा आपलं हे वाटतं की ते बरोबर आहे, but it may be that on some occasion it may not be working properly. It is likely that it is operating properly, but on some occasions it may not work properly. That may be the scenario. Is the idea clear? On some occasions it may not be working properly, and therefore Intel has not published it. Is it okay? So that should be very much clear. Like now there is no point in finding out that because the processor is now obsolete. Attendance. Don't forget it. It is the major task for which few of you might be coming. So it start with zero flag. So what happens is that the destination for decrement instruction, increment into those details I don't go right now, but surely for decrement or even in case of increment as well as decrement, both for both instructions, zero flag and so you get it now. The source for increment and decrement instruction is given register. and destination is a register and zero flag. म्हणजे काय? If that particular bit in the flag register is either set or reset, then as a result of increment or decrement operation, if the net result is zero, लक्षात लगा, if result of the increment or decrement means if the operand which is incremented or decremented is becoming zero, then zero flag becomes 1, and if it is not becoming zero, then zero flag becomes 0. म्हणजे समजा for example MVI B02 decrement B, what will be zero flag after decrement B? 0. MVI B02 decrement B, again decrement B, zero flag will become 1. Is it clear? So increment and decrement एकदम सोपा है. If result of the increment or decrement operation is 0, means the operand which is getting the increment or decrement will become 0, then zero flag is set, otherwise zero flag is reset. Is it okay? I hope it is quite clear. Increment or decrement instruction. Then, so this is data processing, addition, increment, decrement. I think there are many which will go later on. Now we need to go for remaining type of instruction. What is that? Data processing we discussed, data transfer we discussed, data processing we discussed. Now the last group is control transfer. So what happens? Who keeps the track of the instructions? Who keeps track of the instructions? Program counter. When you read a book, you see, go on one by one page. Page number is there. You go on next page, next page. Sometimes, especially in nowadays, that even there are some examples which are given, one may not be able to recollect it or identify it. काही मॅगझिन्स असतात, लोकप्रभा किंवा दिवाळी अंक असतात, तर त्यात कसं असतं का पेपरवर असतं कधी कधी. पेपर कसं असतं, आपण त्या पेपरचं पेज एवढं डोक्यात नाही. पुस्तक आहे, लोकप्रभा दिवाळी अंक आहे. वी स्टार्ट दी फर्स्ट कव्हर स्टोरी, वी गो ऑन रीडिंग, and it is remaining part is not on next page, it is on some other page. So it खाली काय लिहिलं असतं, पान नंबर 52 वर. लक्षात आलं का? पान नंबर 52 वर. Normally it is the program counter which keeps track of the instructions in normal case, but some instructions are also provided which are control transfer instructions, and of them one very simple instruction is jump instruction. Jump address 8, address 16, upward is C3. So I write at 0000 itself we can have jump 5000. The opcode is C30050. So we start, type, address, data. Now you tell me, first type is fetch, program count will give address 0000. Here I write specifically, no need actually. Program count will give 0000, opcode is C3, it goes to IR. So now you complete the next cycles. would happen? Try to guess. First thing very simple. Read 0001 00. Read 0002 50. So what should happen with 0050? Why WZ? Why? See that now you might have answered it correctly, but just I would like to say that if I am stuck up with anything, it is not that it should go to temporary. It should not be a routine answer. So at the end of first machine cycle, 8085 has come to a conclusion that I have read an opcode of 3 byte instruction, that is jump. So I will read next 2 bytes. Next 2 bytes correspond. आता मी जब मी तुम्हाला काही सांगितलेलं नाही ना, इतके obvious आहे. Next 2 bytes of the instruction will provide me what? Address where to jump. Means it will provide me the address of destination program counter. आणि त्यातलं पहिलं काय असणार आहे? C3 0050. आपलं लॉजिक काय आहे? आधी LSB. हे पहिलं काय असणार? प्रोग्राम काउंटर लोअर बाइट. Then can I write like this? At 00 goes to program counter lower byte. Can I write this? Yes or no? Yes. The answer is no. Now you tell me why no? No. Program counter has got 2 parts. Program counter lower, program counter higher. Jump address 16 instruction is a control transfer instruction. It provides next 2 bytes, which is the new program counter. The next byte is lower byte of the program counter. Next to next byte is higher byte of the program counter. But this 00, if I take it to PCL, there will be blunder. What is that? So other than him. Jump, opcode C3, 3 byte instruction, next 2 byte is new program counter. Next byte is lower byte of the new program counter, next to next byte is higher byte of the new program counter. So if, म्हणजे आता LXI B ला काय करतो आपण? LXI B ला 0 opcode आहे त्याचा. पहिलं byte जे आहे ते C ला लोड करतो, दुसरं byte जे आहे ते B ला लोड करतो. Because LXI B instruction wants BC pair to be initialized with the values given the instruction. Jump instruction wants program counter to be initialized with the values supplied in the instruction. So next jump, next byte is new, next byte is PCL, and next to next byte is PCH. But this should not go to PCL. Why? What is the reason? will happen? I said there is a blunder. There will be blunder. What is the instruction? The instruction jump instruction which provides new program counter after the instruction is over. It provides lower byte and higher byte of new program counter. But it is to be read using what? म्हणजे जंप इंस्ट्रक्शन मध्ये पुढची 2 बाईटचे नवीन प्रोग्राम काउंटर आहे. अपेक्षित प्रोग्राम काउंटर ची 2 बाईट्स दिलेली आहेत इंस्ट्रक्शन मध्ये. पण तो इंस्ट्रक्शन वाचायला कुठल्या बेसिस वाचायचे? Using the, are you getting me? This is important. Can you explain?
The lower byte goes in the lower column with the same factors, it will partially update and there will be errors.
So remember that the instruction requires program counter to be initialized. When means if you are cooking some food, you are cooking to eat. You are cooking to eat. What will happen if you eat it before it is completely being cooked? What you intend to eat will not be there. You will eat something else. Is it right? So the instruction is to be executed after it is completely read. And instruction reading is done by program counter. Using program counter, current program counter. So if you put program counter right now was 0, then it was 0001. When it was 0001, it was incremented, so it has become 0002 actually. Before it is expected to be outputted in the next machine cycle. If you make it PCL, then that will become 0. Then 0000 will be there. And you always loop. So where this should go? Then this should go to 0. This is the lower byte of the new program counter which I will be requiring later on. Then this next one, you should go to W, and then what is W and Z? I have 8085 has read the instruction jump 5000 and put 00 and 15 W and Z to be put into program counter. So in the bracket now, is it right? And then upward fetch 5000. So next instruction will be from 5000. Is it clear? Is it okay? It's jump and control transfer instruction. Now to make the programming very convenient, any processor provides branch instruction. It is unconditional branch. It is unconditional branch. Like that, you will find that if you want the things to be appropriate, then there has to be conditional branch instructions. Conditional branch instruction means what? Conditional branch instruction means branch if some condition is met, and don't branch if condition is not met. The condition branch instructions are based on flags, carry flag and zero flag. So there are two instructions, actually there are 4. Jump on carry or jump on no carry. Similarly, jump on 0, jump on no 0. Jump on 0, jump on no 0. Right? Is it okay? So jump on no carry 3000 means this instruction here for unconditional branch we do it directly, whereas this is being done if the condition is met, otherwise program counter is 0003. If carry is not, means jump on carry means jump if carry flag is 1, otherwise don't jump. Jump on no carry means jump if carry flag is 0, otherwise don't jump. Jump on carry, jump on no carry. Jump on 0, jump on no 0. Now I will write a program and I want you to tell what this program will do. And then one more instruction which I forgot to tell, that is a halt. म्हणजे काय? काही करायचं नाही. Once that instruction is read, it goes to dormant state. Jump, halt. Now you tell me what this program does. It's a reverse question. In GATE you may get some, you may be, are you aware that now GATE has added one more paper? You know or don't know? There is data science and artificial intelligence. So in GATE such questions are there, that finding out what program does. What this program will do? Add, it will add two numbers stored at 8050 and 8051 and will store the result at 8052 and 8053. Because addition of two 8-bit numbers can be a 9-bit number. Addition of two 8-bit numbers can be a 9-bit number. So it will add the numbers at 8050 and 8051 and will store the result at 8052 and 53. Is it right? Okay, if you try to understand during the class, you try to understand on your own if you can, otherwise you will just have a revisit in next session. Now there I will add, oh that and just put the line. Now I will explain to you two more instructions. Now, okay, one instruction which we discussed today, but that we had not yet dealt it very clearly, so we'll do that first. So 0000 LXI H 8000, 0003 MVIM 000, LXI is 210080, MVIM 55 means 3655 and 0005 decrement M. Right? This is clear? Opcode of decrement M is, sorry, increment M. Opcode is 34. Opcode is 34. So we write down the machine cycle sequence. No need for first. Just watch. You should be able to say it in chorus. Type. What do you type? Type address data. Fetch 000021 goes to IR. Read 0001 00 goes to L. Read 0002 80 goes to H. Fetch 0003 36 goes to IR. Read 0004 55 goes to M, right? 55 goes to M. 55 goes to Z. What is MVIM? MVIM 55 means write 55 at 8000. Write 55 to memory location whose address is the HL pair. So this goes to Z. Then write who gives address? HL gives address. What is that? 8000. Who gives data? Z gives data. Then opcode fetch. What is that? 0005 34. It goes to IR. Now you tell me what happened. AT85 has read the instruction increment M. So what will do? It has read the instruction increment M. What it will do? Next cycles. Somebody should tell it immediately. What will happen? It is increment memory location. Increment memory location means where is the operand? Operand is outside the processor. If it was increment B, what was being done? In the bracket you are writing B equal to B plus 1. That can't be written anymore here. Why? What is the reason? Because M is outside and microprocessor can't send signal to memory to increment that. So the only way with which it can do is take in, increment and send out. So increment M is a 1 byte instruction, but it requires 3 machine cycles. Next is memory read. Read use address HL 8000. 55 will come. Where 55 will go? Z. And what will happen? Z equal to and then write HL will give 8000 and Z will give. Is it right? So I think it's in the portrait.